Okay, grab a periodic table and we are going to learn how to write formulas for ionic compounds. Okay, so if first when you're looking at the periodic table, you have to know that the periodic table is the list of all the elements, and some of the elements are metals and some of them are nonmetals, and they are listed differently in the formula depending on whether they're a metal or a nonmetal. On the left-hand side of the periodic table, those are all the metals on the left-hand side of this zigzag line that goes under boron, under silicon, under arsenic, under tellurium, under acetine. So that line separates the metals from the nonmetals. So the metals all are listed first when you're writing an ionic compound because they're positive ions when they form. That means that they are giving away their electrons. The nonmetals, which are to the right of the zigzag line here, all gain electrons. Now, there is an exception. There's a slight variance. Let's look at that for a second. Boron actually is on the wrong side of the zigzag line for your ions. Because another way you can look at it is it depends on whether or not you're gaining your electrons, on whether it's easier to get to the number 8 by giving away the electrons in that energy level, or taking in electrons. So the halfway point is carbon and silicon. And so columns number 1, 2, 3, and 4 all can give away electrons and be positive ions. And then 5, 6, and 7 all gain electrons. Column number 8 does not give or take away electrons on a regular basis. It has some exceptions to that rule, but they already have their 8 electrons and therefore don't readily make compounds. So we don't even do anything with those as far as compounds. Those are the noble gases, and I call that the princess column because you're going to see we're going to count how far away these girls on the right-hand side are going to be before they're a princess. So that line roughly separates the cations from the anions. The only exception is boron is on the wrong side of the line originally. Okay, so if we're looking at the box closely on the periodic table, you can see that there's a little number, or sometimes multiple numbers, above the symbol on the periodic table. And those numbers are the oxidation numbers for the element. And we use those as the charges for the most part. Until after spring break, we'll talk about how we know some of the exceptions, but this is how it works. The first column all has a +1 charge. The second column all has a +2 charge. Boron's column has a +3 charge. Now you notice I skipped over this short section of the periodic table, and you have to go look at the box on those to see what the charges are for these, because there's a variety of different charges. Some of these elements have more than one oxidation number, and they'll tell you the number that they're using when they ask you the name of the formula in Roman numbers. So you do have to also know your Roman numbers. So if it's something you don't already know, you're going to need to make sure that happens as well. So if you'll notice, there's a little number 1 over top of the symbol Ag, and that is because silver has a +1 charge. So you write the symbol and charges. That's the first step in writing a formula: symbols and charges. Please remember that the first one is always uppercase and the second letter is always lowercase if it is a 2-letter symbol. That is critical, and it will get you marked wrong if you make both of these uppercase or if you make both of these lowercase. You must have it correct to get the points, because if it's not correct, it's wrong. And if it's wrong, you don't get points. All right, so that's where I'm getting that number from. If I look here, the question said, what's the charge for the iron? And there's a number here after the iron. Roman number 2 is what that is. the iron Roman number 2 ion. So it's telling you with Roman numbers that they're using that number 2 as its charge. So symbol and charge is an Fe plus 2 because they told you. So it's kind of even easier when it's one that has multiple charges in figuring out the formula because they're telling you the charge. All right, so it tells you the charge. So the charge for the anions is not looked at by looking at the symbols on the periodic table and looking over top of it like the boys were. The girls' side of the periodic table, we just count how far away it is from the noble gas column, and that's a minus charge on it. So we're not looking at the oxidation chart numbers. We're looking only at how far away it is from the noble gas column. All right. Eventually, we will understand more about those multiple oxidation states, but that's not for quite some time. So in introductory chemistry, the girls don't have multiple numbers to worry about just yet until after spring break. All you have to do is count how far away they are from the noble gas column. So everybody in this column that's 1 away from the noble gases has a -1 charge. Everybody in the second column away from the noble gases has a -2 charge. 3 away, -3 charge. 4 away, -4 charge. Now, the carbon and silicon are also 4 away from the opposite direction. So carbon and silicon also potentially have a positive charge on them. So they do both things. We'll talk more later about how do you know which thing it does depending on whether or not it's listed first or listed second. So if it's listed first in the formula, it's a positive ion. If it's listed second in the formula and changes the ending of its name, it's a negative ion. Okay, so let's give the symbol and charges for these ions. So iron with a Roman number 3. So you look at your periodic table. Hopefully you don't have to look at your periodic table for very long because iron is one of the weird 11, which means that it has a symbol that does not match its name. So you'll have this one memorized. So Fe and a +3. How about cadmium? When you go search for its square, you should find cadmium and see that over top of the CD, there's only one charge listed there. It is a +2. How about oxide? You'll notice you won't find oxide on the chart because this is a positive ion. When something ends in "ide", it is the second thing in your formula and indicates that that's a negative ion, and that changes its last name. So go look on the chart for the word closest to oxide, and you'll find that it's oxygen. Oxygen is 2 away from the noble gas column. So that is a -2. All right. Now you'll notice it's mentioned here that you can say it +3 or 3 plus or +2 or 2 plus. That's fine. Either way, please be sure we're just learning, so we have to put the charges because I have to know whether you know it's positive or negative. It's kind of a critical aspect. We always put our positives first in the formula and our negatives second. And the only exception to having a number with your positive or negative sign is if you have a 1. Sometimes they just put a negative. But let's go ahead and write the full thing out for quite some time until we're sure we both know that you know what you're talking about. All right. So oxide was a -2. How about phosphide? Well, it's "ide". That's an indicator that it's going to be on the right-hand side of that cootie line, the zigzag line that separates the boys from the girls on this chart. And so go find that. You'll see it's a P. Then you're going to count how far away is phosphorus from the noble gas column. It's 3 away, so it is a -3 charge. Okay. So how about zinc? Zinc is not changing its name, so it's on the left-hand side of the zigzag line. It only has one number over the box, over the symbol in the box, and that is a 2. So it is a positive 2. All right. Chromium. It even tells you it's a Roman number 2. Since it tells you it's a Roman number 2, it is a Cr plus 2 because it's saying it's a plus 2. And then barium. So go find barium. It is a Ba plus 2. It's in the second column. Everybody in the second column is a plus 2. So it's in the tall columns, and the tall columns always are. Everybody in the first column is a plus 1. Everybody in the second column is a plus 2. So I don't even have to go look carefully at it. I can just see where it is on the chart and know it's a plus 2. All right, here's a list of additional ions to check out. Go ahead and pause the video right here and do these 7 problems. When you've finished the 7 problems, resume the video and you can check out the answers. Go ahead and pause the video now. Okay, hopefully you have the correct answers. Here's the check of your answers. Copper with a Roman number 1, Cu plus 1. Indium, when you go search out indium, you'll see that there's only one number over the box for indium. It is a In with a plus 3 or a 3 plus. All 3 ways are okay. I mean, both ways are okay. The one that has 3 ways is when it's 1. You could just put a plus sign there. Sulfide. Hopefully you noticed that it ended in "ide," which means it was on the right-hand side of the zigzag line. And so when I go to the right-hand side of the zigzag line, I see that that is S, and it's 2 away from the closest noble gas. So that is S minus 2. Nitride, the ide also once again tells me it's on the right-hand side of the periodic table when I go to look for it, and that is an N minus 3. It's 3 away from the closest noble gas. Scandium, when you go look for scandium on the periodic table, you'll notice that there's only one choice for scandium. It is a plus 3. Nickel with a Roman number 2. That's going to be Ni plus 2. And magnesium with being in the second column lets you know automatically, without even looking carefully, that it is an Mg plus 2. So hopefully you got all of those right on your check, and we can move forward to writing formulas. The first step is symbols and charges. That's what we just did there. That's the first step in writing a formula. So here are the steps. You can write them down on a piece of paper so that you can refer back to them when you're doing your practice problems. So the first thing is determine the charge. I usually say symbols and charges. So you'll hear me say, first step, symbols and charges. Second step, reduce if you can. So if your symbols and charges can be reduced, you will do that. Then drop the signs. Make sure you never have positive or negative numbers in your formulas. And then switch to subscripts. You're going to put the two superscripted charges down to the bottom as subscripts, and you're going to switch them. They're going to zigzag across the formula. I'm going to show you that with an example, and then I'm going to have you do a couple examples on your own. All right, so we've got rubidium selenide. So what's the first step? The first step is symbols and charges. So you go find rubidium on the periodic table. It's an Rb, and it is in the first column, so it's a plus 1. Selenide, the ide let me know that it was on the right-hand side of the zigzag line. By the way, also the first ion, the positive ion, is always on the left side, and the negative ion is always on the right side. That's how they're written in the formula by their electronegativities, and so it's always going to be that way. So selenide, I go find selenium, and it is an Se, and how far away is it from the closest noble gas? It's 2 away from krypton, so it's a negative 2. Okay, so the first step is symbols and charges. It's writing those symbols and charges. So Rb plus 1, Se minus 2. Second step, reduce if you can. Well, you can't reduce a 1 and a 2 because 1 is far down as it can go. So check, it's already reduced. Drop the signs. So we don't want to have symbols that have charges on them when we write our formulas. So we're dropping the sign now. We're dropping the positive and the negative number. And then we're going to switch them to subscripts. So when I say switch them, the RB is going to get the 2, and the SE is going to get the 1, and we don't ever write the number 1 in a formula. Now you might ask yourself, okay, well, why did we do that switcheroo? Because compounds are neutral. And if we go back up here and we look at this RB plus 1 and the SE minus 2, if you were to add those two things together, you still come out with a -1 charge, and compounds can't have a charge. So you need another RB to neutralize the SE. Now, if I put this together, 2 pluses, 2 minuses, now I do come out to neutral. And this is a neutral compound then. So how many times did I have to write RB to make that neutral? 2 times. How many times did I have to write SE to make it neutral? 1 time, and we don't write the ones. So you see, if I just switcheroo, I can come up with the exact same ratio. All right. So symbols and charges, drop the sign after you've reduced, and switch to subscripts. Mind you, there are other teachers that may tell you to do the reducing at the end. I'm just a little lazy, then you have to rewrite stuff one more time. So I reduce up at the top, then I don't have to worry about reducing later. I also make it to where sometimes when I have polyatomic ions, I don't make the mistake of reducing the oxygen on our polyatomic oxyions. You'll understand what I mean on Friday. Okay, so what is the formula for titanium? That's a Roman number 4, telluride. Pause the video, do the steps, and then restart the video to check it out. Okay, first step, symbols and charges. So symbol Ti with a +4. Telluride, Te, that's 2 away from the closest noble gas, -2. Simplify. I could reduce this 4 and this 2. Then my numbers end up being a 2 and a 1. Drop the signs. Okay, so you'll notice I kind of prematurely did that because I know what the next step is. So I'm not going to have any signs in my compound name. My formula doesn't have pluses or minuses in it, so never have pluses or minuses. So then the switch to subscripts. So the Ti is going to get the 1, which we don't write. I already didn't write it. And the Te is going to get the 2. All right. So first step, symbols and charges. Second step, reduce if you can. Third step, drop the charges. Fourth step, switch to subscripts. Remember, we don't write a number 1 as a subscript. All right, here's another one. Pause the video and give it a try. Okay, what's the formula for strontium nitride? First step, symbols and charges. So strontium Sr +2 because it's in the second column, and nitride N-3. Reduce if you can. 2 and 3 don't reduce, so they're still 2 and 3. Drop the signs. I don't want to have pluses or minuses in my formula at the end. Number 4, switch to subscripts. Sr is going to get the 3, and N is going to get the 2. Okay, because it's going to take 3 SRs to balance out 2 Ns to make a neutral compound. Once again, another practice problem. Pause the video and come back once you've solved your formula. What is the formula for calcium oxide? Okay, so first step, symbols and charges. So Ca plus 2, it's in the second column. And oxide, that's oxygen, and it's 2 away from the closest noble gas. Simplify or reduce if you can. We can. Both of these can be divided by 2, and they both end up going down to 1s. Drop the signs. Don't put any charges in a formula. We never have charges in a formula. And then switch to subscripts. So the Ca is going to get the 1, which we do not write, and the O is going to get the 1, which we do not write. So calcium and oxygen are there in a 1-to-1 ratio in order to make a neutral compound. All right, that is how you get from the name to the formula. Now we're going to go from the formula to the name. So to go from the formula to the name, you have a formula to start out with, and you're going to write the name of each of the ions. So the first thing you're going to write is the name of the cation. That's the positive ion. See the little plus sign there? That's the thing that is on the left-hand side of the periodic table is the positive ion. Okay, so positive is going to be listed first. Then the second thing you're going to do is ask, is that element a liar? And the reason I say that is the first 2 tall columns on the periodic table, they don't lie. They're always going to be +1 and +2. Okay, so those 2 columns are always +1 and +2. But there are a lot of guys in the short section of the periodic table that has more than one oxidation state, and those are the ones we have to write a Roman number for. So if it is one that has more than one oxidation state, when you go look up its name, you're going to write Roman numbers in a parentheses, but just write the parentheses for now because you have to do a little bit of math to figure out the numbers. So then you're going to switch, undo the switch of the subscripts that you did. Remember, we switched down to subscripts. So to undo it, we have to switch back up to our superscripted charges. Okay, so when we switch back up, we're going to have 2 numbers to look at. And you have to go check the number on the anion, the number on the negative ion. You have to go check if that is, in fact, how far away it is from its closest noble gas. Because remember, it could have been reduced, which means we have to unreduce it. Whatever happened to the negative ion also happened to the positive ion. So we will have to unsimplify, unreduce what we did. And then if it has a Roman number, you're going to write the Roman number in the parentheses. All right, so let's give it a try. Cesium is the CS's name. Okay, so I'm going to write that down first. And then sulfur is the S. But remember, we changed the last name in the negative ion. So it's going to say sulfide. So make sure that you don't say sulfur here. You have to say sulfide. That's because when we write a formula out of it, we change its last name to IDE, okay, to indicate that it is an ion, a negative ion. All right, is cesium a liar? Go find cesium on the periodic table and see if there is more than one charge over top of the CS on the periodic table. And no, it isn't. So it is just cesium sulfide because it's not a liar. So if it doesn't have more than one oxidation state, I don't need Roman numbers. Then I look to here to see it only if there is a Roman number, how to do the unswitch. I don't need that because it's not a liar. And so it's not going to have Roman numbers. Cesium is always a 1. And so you're finished already. The minute you see that it's not a liar, your formula is done. All right, so you're going to go ahead and give it a try yourself. I'm going to give you a formula, and you are going to come up with the name of it. So you could refer back to this slide if you have any trouble solving your problem. Okay, so here's the problem. Capital letter C, lowercase u, and capital O. Pause the video and write the name of this compound. Okay, so the first thing you did was you wrote the name of your ions. Okay, the first ion that we have there is copper. Then you've got to go look on the periodic table and ask, is copper a liar? Does it have, when you look at the little box that has Cu on it, does it have more than one number floating over top of the symbol? And if you look, you'll see there are 2 numbers there. And that means that copper has more than one oxidation state, which means you have to tell the reader which one it is. And to do that, you do it with Roman numbers. So you're going to put parentheses. The second thing you do is you go look up what element has the symbol O. When you go look up that symbol, it's actually oxygen. And we drop the ending of the word and we add IDE. So it's oxide. That one you should know pretty readily since it's a very common compound and you've probably heard of multiple things with oxide in it. So copper was a liar. We need to figure out what is the Roman number. So we're going to do the unswitch of the elements charges here. So we're going to do an unswitch. So it looks like there are no numbers in this formula. So when you see no numbers, you know that it must be a 1. So that's a positive 1 and that's a negative 1. But what if this was reduced? How do you know if this was reduced or not? Because you go look and you find oxygen on the periodic table and you see what is its charge. Well, you'll notice it's 2 away from the noble gas column. So actually, oxygen is really a -2. It's not a -1. So what had to have happened to make this 1 in the formula? It had to have been reduced. So whatever you did to the oxygen, you did to the carbon, because that's how you reduce something. They had to have both been reduced by the same thing. So obviously this was divided by 2. So that means this over here had been divided by 2 as well. Or you can look at it this way. What do I have to do to get it back to its real number? I have to times it by 2. So I have to times that by 2. So what is the +1 times by 2? It's a 2. That's how I know what Roman number to put into the formula. So Cu looks like a 1 and oxygen looks like a 1. But when I go look it up on the chart, I see that the oxygen's actually a 2. So that means that the copper had to have been a 2 because whatever happened to the oxygen happened to the copper. So when I rewrite that, I have a copper Roman number 2 oxide. Please don't forget to put the oxide. You can't say copper Roman number 2 oxygen. That's wrong. All right, so go ahead and write the name of this compound. Pause the video and solve the question. Okay, first step is write down the names of your ions. So I've got iron, and I go look to see, is iron one of the elements that has multiple oxidation states? And the answer is yes. So I'm going to put Roman numbers. I don't necessarily know what they are right at this minute, but I will find that out in a second. Before I do that, I'm going to go look to find Te on the periodic table. It's tellurium. I dropped the IUM and I put IDE. It's telluride. Now I'm going to uncross the elements, undo the switch. So I'm going to undo the switch here. It looks like Te was a -2. And if that's true, then the Fe in this case was a +3. Is Te 2 away from the noble gas column? Yes, it is. So it didn't get reduced at all. It is just a 3 on the iron's charge. So check to see whether telluride was a -2, and it was. So it was just switched. It wasn't reduced. So then we write the Roman number, iron Roman number 3, telluride. Iron Roman number 3, telluride. All right. Hopefully that helped.